The first sprite node we are going to create will just be a simple red box. That is not as boring and useless as some of you may think now, because oftentimes in actual games and projects, we will use these red boxes as placeholders before adding actual graphics or images, just to quickly test how scenes could be built. This concept is actually called red boxing, and it is widely used with developers because of the possibility to really quickly test stuff without having to create or wait for graphics, by simply using red boxes or boxes instead. I will now, right below my first node, create a constant, my first sprite node, which I will set to a new SKSpriteNode. As soon as I open the parentheses here, we will see that we have a lot of different ways of initializing an SKSpriteNode. However, they are all pretty much self-explanatory. The one at the top that we could use, for example, just asks for a color and size. There are others for initializing from a file, from an image, or as a texture with different colors and sizes. However, we will now start with the simple one, like I said, and as the color I'm going to write UIColor.red. And the size will be defined as a new CG size instance. A lot of elements of the SpriteKit framework, like sizes, floats, and such, are using types from the core graphics framework, which is what the CG here stands for. A CG size is initialized with a width and a height, and the first parameter is the width, which will be set to 200.0. And then we're going to set the height to 200 as well. This should result in a red square, which is 200 pixels wide as well as high. You might remember this from the SKNode video. We still have to actually add the sprite node to our game scene, and we can once more use the addChild method to do so. Inside of the didMoveToView method, I am going to write addChild and pass my first sprite node as the argument for the method. Now we can run the app, and if it works, we should be able to actually see our red square on the screen. And as you can see, it is visible in the bottom left corner here. We can also see our node count has increased to 3, since we now do have our scene, our node, and our sprite node inside of this view. However, I don't really like where our sprite node is positioned. I would prefer having it right in the middle of our screen so that we are able to see it completely. To fix this, I will stop the app. We will now have to set a property for our sprite node, the position property to be exact. To do so, I will, above the second addChild call, write my first sprite node.position and set it to a CG point. Once more, a type from the core graphics framework. A CG point defines a point that has certain coordinates with an x and y value, just like in an ordinary coordinate system that you are probably familiar with. To position our sprite node right in the center of our scene, we have an awesome shorthand to get the exact point that we need. We can just use the frame property of our game scene, which is the rectangle that encloses our scene, and the frame property itself has some default values that we can access. So for example, we can just set the x coordinate to frame.midx, which is the x value right in the middle of the width of the frame. And the same thing goes for the y value, which we will set to frame.midY, which is the middle of the height of the frame. These two coordinates combined position our sprite node dead center in our scene. So let's run it. Wonderful, just like we wanted. But still, something seems a little odd when we think about it. We have actually positioned our sprite node right in the center of the screen. If this would work like placing actual UI elements in ordinary applications, our square should actually be a little offset to the top right and starting from the center. However, it isn't. And this is because every sprite node has an anchor point property, which is by default set to 0.5 and 0.5. What this means is that the point that will be set to the position defined is right in the middle of our sprite node. Let's take a quick look at this property now by changing it, so that our actual bottom left corner is placed on our CG point for the position. To achieve this, we will, below the position line write my first SpriteNode.anchor point, which will also be a CG point, and the anchor point has coordinates between 0.0 and 1.0, where 0.0 would be all the way to the left for x and all the way to the bottom for y. 1.0 would be accordingly all the way to the right for x and all the way to the top for y. To position our anchor point in the bottom left corner, therefore we need to set the anchor point to 0.0 and 0.0. We can do this just like we did with the position, meaning just adding the two values like so. However, we have also a shorthand for this specific CG point simply by writing cgpoint.0. If we now run it again, we will see that the position is still the center. However, now the bottom left corner of the sprite node is placed there, and therefore our sprite node is offset to the top right. Exactly what we expected. And now we already know quite a bit about positioning our red box. For learning all this, the red box was very helpful and awesome. But it would be really cool to add actual graphics now, and therefore we're going to create our first sprite node containing an image. Let's have a quick look in our asset catalog, in our project, and if we open it, we can see that we already have a default image in our project, which is this spaceship. So we will just remember its name, which is spaceship, and go back into our game scene. Now we will create a new constant called myFirstTexturedSpriteNode and set it to a new SKSpriteNode. This time, however, we will choose the initializer that says ImageNamed for its parameter. For this parameter, we will write spaceship, which is the actual name that the graphic has in our asset catalog. And just like that, we have created a sprite node with a spaceship graphic. The sprite node will be a little special since we do not want to solely add it to our scene like the other two nodes, but as a child of our first sprite node, the red square. It is really similar to ordinary apps with views and subviews, and we can just add nodes as children to other nodes. We will also use the addChild method for this, but we won't call it on our scene directly like we did before, but we are going to call it on myFirstSpriteNode. So let's write myFirstSpriteNode.addChild and then pass myFirstTexturedSpriteNode. What this means is that the spaceship will not be positioned in the coordinate system of our scene, but in the coordinate system of myFirstSpriteNode, which has its own origin point right in the center of our scene. So if we do not change the position nor the anchor point of our spaceship, its center will be positioned right in the middle of our scene. Other than being placed in the parent's coordinate system, child nodes will always mirror any changes or manipulation executed on their parent. So if we, for example, scale myFirstSpriteNode or change its position, it will always affect myFirstTexturedSpriteNode as well. And that is something that we have to keep in mind. So let's run the app and see if our spaceship is positioned where we expect it to be. Just like we thought, the spaceship is right in the center of our view. Again, the reason for this is that the parent node's coordinate system originates at the center of our scene. And since the anchor point of our spaceship is right in the middle of the node, it gets put right in the center like we see here. Our spaceship is a little big as of now, so to fix this, we will now take a look at yet another property of SpriteNodes, the size. Above the line where we add the spaceship, I'm going to write my first textured SpriteNode.size and set it to a CGSize instance, very similar to how we did it with the initializer of the red box, right at the top. I will just set width and height to 100.0 each, and then run the app again. Our spaceship should now be significantly smaller, about a quarter of our red box's size. And as we can see, this worked. I think you are now ready for a small challenge, since we do now know quite a few things about SpriteNodes. I want you to add another box to our scene, but make it a blue one. You can choose the position and anchor point however you want, but please do make it a child of our red box, just like we did for the spaceship. So why don't you pause the video real quick and give it a go. I really hope you managed to do this, and I'm going to below my first texture, SpriteNode, add a new constant to show you how it's done. It will be called blue box, and I'm going to initialize it as an SKSpriteNode with the color, as you may have guessed, UIColor.blue, and the size, CGSize, with 100.0 for both width as well as height. Next, just like we did with our spaceship, I'm going to write my first SpriteNode dot add child and add the blue box as a child to the red box. I will not change the position nor anchor point, so we should have the box right where our spaceship is located. If I run the app, we can see that this works and the blue box is visible right below our spaceship. Some of you might remember that when we first created the project, we saw the ignore sibling order property of our view, and back then I told you that we will get into this later. Let's just take another look in the game view controller where we have this line here and it gets set to true. What this means is that this SK view will not pay attention to the order in which children are added to it. Therefore, it can't be certain whether the blue box is shown above the spaceship or below, since the children are just rendered and drawn in the order that allows for the best performance, which is a good thing. But it can also be a bad thing, since it may lead to some nodes getting placed above other nodes, where we do not want that to happen. But we do have a possibility to force how we want our nodes displayed. We want to demonstrate this by always showing our blue box above our spaceship. To do that, we will use another SpriteNode property called setPosition. It determines whether nodes are drawn above or below other nodes, or how close or far away nodes are. We will begin with my first textured SpriteNode, and using the dot syntax, access the setPosition property, which we are going to set to 1. Next will be our blue box, and we will do exactly the same, but set the value to 2. Higher values for set positions do always mean that this node is closer to the foreground, so our blue box should now be drawn above our spaceship. Let's run the app once more to see if this actually happens. Perfect! Our spaceship is still present, however we do not see it anymore, since the blue box is now drawn above it, just like we specified with the set position. To end this video, I have another challenge for the really smart ones among you. Why don't you try to position our blue box right in the center of its parent, the red box? A little hint, our red box is fully initialized by the time we add the blue one, so we are able to access all of the properties of the red box, and we can use some of them to position our blue box. So pause the video and try and see what you come up with. Okay. All we need to add is setting the position property of the blue box here, and we do so by writing bluebox.position and setting it to a new CG point. In this case, we will not just pass absolute numbers, but make them dependent on my first sprite node, our red box. For the x value, I will say my first sprite node, and the width dot syntax accesses the size property as well as the width. This gives me the width of our red box, which I then want to divide by 2 to be right in the middle of the width. For the y value, we do exactly the same, with size.height divided by 2. Since the red box is a square, we could of course use the same value here, but we want to do it completely correct with height for the y value, because then it would also work for rectangles. I will now run the app one last time and hope that this works. Perfect. Our blue box is right where we want it to be, and we have learned a lot about sprite nodes and what we are able to do with them. We can initialize them, add them to our scene or to other nodes, and handle their most important properties such as size, position, anchor point, or Z position.